Howdy there, geometry class, my wonderful geometry students. We're going to do a lot of application problems. This day is extremely important. I can't emphasize how extremely important it is. Your test, without joking, it's half of the points on your test are application problems. Half of the points on your quiz is these application problems. So close the extra Facebook window that you have open right now. Yes, I know these things. I know it's open. Okay, close it. Eliminate any distractions and really focus here because these problems aren't all that easy. So let's start with this first one. Well, some suggestions on these application problems. Number one, draw a picture. Draw a picture on all of these, okay? And that's going to seem obvious here in a minute that you need to do that. Number two, kind of read through the whole thing because it's hard to tell like where to place what items where. And the other thing I would recommend is label everything you possibly can on your triangles, okay? On your pictures, label stuff that you can. It might end up being useful later. Okay, so let's read this out. The angle of elevation to an airplane from 2 points A and B on the ground are 51 degrees and 68 degrees respectively. Now, I could just, put, declare this A, declare this B. Now, where's the plane, right? Okay, the plane has to be 51 degrees, so is the plane over here? But then later on, it says that the plane is east. Okay, this is what I'm saying. Kind of read through it. You might have to read through it a couple of times first before you really get an idea of the picture. This is a good idea to have a pencil and an eraser because there's going to be several times you're going to probably need to redraw the picture. Okay. So if the points A and B are 2.5 miles apart, so I'm declaring this to be point A, I'll declare this to be point B. That distance is 2.5 miles apart. And the airplane is east of both of these points. So east, remember like never eat soggy waffles. East, that's that direction. So the plane is somewhere over in this direction. Let's see here. And it says that it's the angles of elevation from A and B. So A is here, and this person's like looking, when he looks straight ahead, this is what he sees, but then he looks up to this plane, and that's our angle of elevation of 51 degrees. And then from B, it's at 68 degrees, okay? So when that person looks straight ahead, here's what that person sees. And then when they look up at the plane, that's the angle of elevation that they're talking about. That's 68 degrees. Respectively, that word just means one after the other. So it went point A to point B, so 51 degrees is the angle of elevation from point A, and 68 degrees goes with point B. Okay, so what else do we have here? Find the altitude of the plane. Okay, find the altitude. So the plane, the altitude would be like this distance is what we want to come up with. So I'll call that H, and I'm noticing I have a right triangle over here. Let's try and take this one step at a time. Now, if I look at this triangle on the left side, it would be really nice if I could use law of sines or law of cosines on that, but the problem is I don't have all the angles there. I don't have enough angles there or sides to do law of sines or law of cosines. So let's figure out, well, I can tell you how big this angle is on that triangle. So this is step one. So that way later on when you're trying to study this, because it's going to look like, oh, you just knew all this information. We didn't. Okay, here's the first thing we're doing. 180 degrees take away 68 makes this angle 112 degrees. Oh, well then that makes it really easy to figure out how big this angle up here is. So here's step number two. That angle has to be 180 degrees for a triangle minus 51 and 112 for the other two angles makes this angle 17 degrees. Okay, what else can I use here? Well, okay, so I need to figure out this side over here, H, and I'm noticing that that's part of a right triangle. Gosh, right triangle. Oh yeah, right triangle trigonometry. Sine, cosine, SOHCAHTOA, right? Sine would be opposite over adjacent or opposite over hypotenuse and all that good stuff. So if I figured out how long this hypotenuse side was, which is something that both the red triangle and the blue triangle share, I'll call that side A because it's opposite angle A. In any case, so if I can figure out how long that side is on the red triangle, the triangle on the left, then I could use like the sine of 68 degrees is a ratio of this side to this side, and then I would know how big A is and then solve for H. So let's work on step number 3. So step 3 is getting to solving for side A? Well, let's use the law of sines because I do have the 17 degrees and the 2.5 miles to match up together. So side A divided by the sine of its opposite angle is 51 degrees has to equal the distance 2.5 divided by the sine of its opposite angle, 17 degrees. Multiply both sides by sine of 51, so I have 2.5 sine of 51 over sine of 17 degrees. And then you get A is about 6.65 miles. Okay, so we're going to store that number in our calculator. So now that I know that this length is 6.65 miles, now we can use the right triangle trigonometry, which SOHCAHTOA only applies for right triangles. So I can use the sine, so this is like step 4. So if I do the sine of 68 degrees on that triangle, 68, this side is what we're looking for. We know this side is a stored number in our calculator. The sine of 68 degrees is a ratio of the opposite to the hypotenuse side. So I'm going to multiply both sides by that stored 6.65 number, and that gives me about 6.16, we'll call it, we'll go and round to nearest tenth, 6.2 miles. Cool, so that's the height of the airplane. So keep your answers always stored in your calculator, and go and just round them all to the nearest tenth. Next problem. A boat is sailing due east parallel to shoreline at a speed of 10 miles per hour. At a given time, the bearing to the lighthouse is 72 degrees southeast. All right, back up for a second. What the heck does that mean, a bearing to the lighthouse? We need to talk about that. Let me get to a blank spot here. Okay, whenever we say a bearing, the key there is that it's the angle made with the north-south line. North-south line. Draw a north-south line every time they talk about a bearing. So let's say that I had a bearing of south 28 degrees east. Okay, so think about, this is north, south, east, and west. So if I'm headed in the southeast direction, so this is me walking along here, southeast direction, I am 28 degrees away from the north-south line. So this is my angle, 28 degrees, when I'm talking about that bearing. Or if I had a different bearing, let's say I had a bearing of, let's go north 72 degrees west, let's say. Okay, well, if I'm walking in the northwest direction, northwest, that means that I'm going in this kind of a direction here, but then it says that it's 72 degrees. That means it's 72 degrees made with your north-south line. Every time it's made with a north-south line. Do I have enough lines here to get that across to you? North-south line. Okay, back here. Okay, so a boat is traveling due east to a shoreline, or parallel to the shoreline, at a speed of 10 miles per hour. At a given time, the bearing to the lighthouse is south 72 degrees east, and 15 minutes later, it's south 66 degrees east. Now I'm thinking, both of these are in the southeast direction. So the lighthouse is somewhere to the south and to the east of this boat. So I'm going to draw my boat up here, like in that corner. And at first, so here's my lighthouse. There it is, shining its light. All right, so then it says it's traveling due east, so going in this direction at 10 miles per hour. And it says that at first, at a given time, the bearing to the lighthouse is 72 degrees southeast, meaning that if we drew a line going in the southeast direction and we made what kind of a line? A north-south line, okay? That this line that we just created is 72 degrees away from the north-south line. Not this east-west line, the north-south line. Okay, at a given time, we did that one. 15 minutes later, so it's traveling along here, and then right here, it's been 15 minutes, let's say, at this point. So he's here now. Dun, dun, dun. And he's now got a bearing of 66 degrees south and east. Okay, so to the lighthouse, and wait, which angle is the 66 degrees? Oh yeah, it's made with that line that I just drew going in the southeast direction, and it is from the north-south line. That angle is 66 degrees, okay? Did you follow that? He's headed in a southeasterly direction here, and then it says that's bearing, so that means that it's made with the north-south line. Okay, what do they want to know? Find the distance from the boat to the shoreline. So here's our shoreline here, okay? The boat was traveling parallel to that shoreline, traveling east, so that shoreline is going east to west. Anything else on here I need, or I have? Find the distance from the boat to the shoreline. So figure out how long that distance is there. Anything else on this picture you can see we can label? Anything at all? I see a few things. So I'm going to label this like with different steps again. So we know that this angle has to be 90 degrees, first of all. So I'm going to say that this angle then here has to be 90, so I'll call that step 1. That angle is 90 plus 66 degrees, giving us a total of 156 degrees. Anything else that we can label? Oh yeah, it says that it took him 15 minutes. So 15 minutes. Well, this is him traveling at 10 miles per hour. 15 minutes is a quarter of an hour. So times that by 0.25 hours, and the distance that he's gone is 2.5 miles in that amount of time. See how I'm getting some stuff labeled on this oblique triangle over here? I've already got one angle. I've already got one of these sides. Anything else on there we can label? Oh, wait, that was step 2. Step 2. Okay, I was so excited because I noticed that this angle over here is also a right angle. So that means that this angle, call that step number 3 that we came up with, has to be 90, take away 72 degrees. So that angle there is 18 degrees. So looking at that particular triangle, maybe I'll put it in yellow. So I'm looking at that triangle there. On that triangle, I've got an 18 degree angle, 156 degree angle. I could figure out the last angle. This side is 2.5. Let's go ahead and figure out how long that last angle is. So we'll call that step 4. That angle is 180 degrees. Take away the 18 and the 156 degrees, leaving us with 6 degrees there. So this angle is 6 degrees. Well, now I can use a law of sines, law of cosine, probably law of sines actually would do it, to figure out any of these other sides that I want. So now I got to ask myself, well, what sides do I want? We eventually need to figure out how long that distance is. I'm noticing another right triangle over here. I really don't have very much labeled on that right triangle, very, very little. I've got the 72 degree angle. If I was able to figure out another side on that triangle, then I could use SOHCAHTOA to figure out how long this distance was I'm looking for. But I noticed that both the yellow triangle and the blue triangle share this side. So I'm going to call that part X. Call that X, call that X. So that's my goal right now, is to figure out X, and if I know X, then I can figure out how big D is. So we're onward to step 5. Let's go ahead and use the law of sines on that triangle to figure out X. So let's see here. 2.5 divided by the sine of 6 degrees has to equal X divided by the sine of 156 degrees. Multiply both sides by 156. X is 9.7 miles. Cha-ching. Now, step 6. We know how long this is. I can now use, let's see here, which trig function for a right triangle can I use to relate the adjacent and opposite side? That'd be cosine. So the cosine of 72 degrees equals adjacent over that stored 9.7 number. So I multiply both sides by the stored 9.7 number, and I'm getting approximately 3 miles. I mean, it comes out to be 3.006, so I'll call an even 3.0 miles. Please label your units here. Okay, my answer is 3 miles. So we got 2 more to go. Go ahead and watch the second video coming up, part 2.